Download this code from codegive.com, link in the description below. OK, let's dive into Elasticsearch's domain-specific language, DSL, specifically focusing on version 7.x, while largely applicable to version 8.x, and with some compatibility considerations for older versions like 6.x. I'll aim for beginners while providing depth and practical code examples in multiple languages, primarily Python, but with hints for others. I'll touch on version 4, but since it's quite old, the focus will be on version 7 and 8. Disclaimer: Elasticsearch is a complex system. This tutorial aims to provide a solid foundation, but further exploration and practice are highly recommended. Remember to refer to the official Elasticsearch documentation for the most up-to-date and accurate information. Table of Contents. 1. Introduction to Elasticsearch and the DSL. *. What is Elasticsearch? * What is the DSL and why use it? * JSON structure and basic concepts. 2. Setting up Elasticsearch. * Installation, quick overview. * Connecting to Elasticsearch, Python example. 3. Basic DSL queries, understanding the building blocks. * match_all query. * match query, full text search. * term query, exact value. * range query, numeric and date ranges. * exists and missing queries, checking for fields. * ids query. 4. Compound queries, combining queries for power. * bool query, must, should, must_not, filter. * constant_score query. 5. Aggregations, extracting insights from your data. * terms aggregation, finding top terms. * range aggregation, bucketizing numeric data. * date_histogram aggregation, time series analysis. * average, min, max, sum aggregations, numeric statistics. 6. More advanced DSL features. * highlighting, showing relevant snippets. * sorting, ordering results. * pagination, dealing with large result sets. * scripting, advanced data manipulation. * boosting, influencing relevance. 7. Mapping, defining your data structure. * explicit mappings versus dynamic mappings. * data types, text, keyword, numeric, date, boolean, geo. * analyzers, tokenization and filtering. 8. Index management. * creating and deleting indexes. * index settings. 9. Security considerations, brief overview. 10. Troubleshooting common DSL issues. 11. DSL for version 4.x, key differences and adaptations. 12. Best practices. 13. Further learning resources. 1. Introduction to Elasticsearch and the DSL. * What is Elasticsearch? Elasticsearch is a distributed, RESTful search and analytics engine. It's built on Apache Lucene and is designed for horizontal scalability, high availability, and real-time search capabilities. It excels at searching, analyzing, and visualizing large volumes of data. It's often used for * full text search, example website search. * log analytics. * security information and event management, SIEM. * business analytics. * application performance monitoring, APM. * what is the DSL and why use it? The Elasticsearch DSL, domain-specific language, is a JSON-based query language used to interact with Elasticsearch. It allows you to define complex search criteria, aggregations, and other operations in a structured way. Key advantages of using the DSL. Asterisk flexibility, asterisk express intricate search logic. Asterisk compatibility, asterisk combine queries and filters for targeted results. Asterisk performance, asterisk Elasticsearch is optimized for processing DSL queries efficiently. Asterisk readability, asterisk although initially complex, well-structured DSL queries can be relatively readable. Asterisk reproducibility, asterisk DSL queries are easily stored, version controlled, and re-executed. Asterisk json structure and basic concepts. The DSL is built upon json, JavaScript object notation. It uses key-value pairs to represent search criteria and instructions. Here's a simplified illustration. Asterisk query, this is the top-level element for specifying search criteria. Asterisk match underscore all, a specific query type that matches all documents in an index. Asterisk, an empty object, indicating that the match underscore all query has no specific parameters. 2. Setting up Elasticsearch. Asterisk installation, quick overview. Elasticsearch can be downloaded from the official website, https://www.elastic.co/download/elasticsearch, https://www.elastic.co/download/elasticsearch. Installation instructions vary depending on your operating system, Linux, Mac OS, Windows. Docker is also a popular way to run Elasticsearch. Asterisk Docker, recommended for testing. Remember to replace 7.17.14 with your desired 7.x version. The same is true for any version used below. Asterisk connecting to Elasticsearch, Python example. We'll use the Elasticsearch Python client. Important notes asterisk. Asterisk adjust the host and port if your Elasticsearch instance is running on a different location. Asterisk for production environments, configure proper authentication and security settings. Asterisk for later Elasticsearch versions, 8 and up, by default, you may need to authenticate using an API key and HTTPS. You'll need to generate an API key within Elasticsearch first. Example 3. Basic DSL queries, understanding the building blocks. Before we dive into code, let's assume we have an index named my_index with documents that look like this. We'll create this index and add sample data later. Let's focus on the queries first. Asterisk match underscore all query. This query returns all documents in the index. It's often used for testing or when you need to retrieve all data. Asterisk match query, full text search. The match query is used for full text search. It analyzes the query string and searches for matching terms in the specified field. It's suitable for searching text fields like title or description. Important asterisk the match query uses the analyzer defined for the field. The default analyzer tokenizes the input text, splits it into words, converts to lowercase, and removes stop words. Asterisk term query, exact value. The term query searches for documents where a specific field has a precise value. It's ideal for fields like genre, author, or publication _year where you want an exact match. Keypoint asterisk notice the dot keyword suffix. By default, Elasticsearch indexes text fields in two ways. Asterisk text, for full text search, analyzed. Asterisk keyword, for exact value matching, not analyzed. If you don't use dot keyword, the term query on a text field will attempt to match the entire analyzed field, which usually doesn't work as expected. In older versions, pre-5.x, you might have used not_analyzed instead of .keyword. *range query, numeric and date ranges. The range query allows you to search for documents where a field falls within a specific range. It's useful for numeric fields like publication_year or rating, or for date fields. Range operators *GTE, greater than or equal to. *GT, greater than. *LTE, less than or equal to. *LT, less than. *exists and missing queries, checking for fields. These queries check if a field exists or is missing in a document. The missing query has been replaced by the must_not clause with an exists query. To find documents without a description, equivalent to the old missing query. *ids query. This query retrieves documents based on their unique IDs, _ID field. 4. Compound queries, combining queries for power. Compound queries allow you to combine multiple queries to create more complex search logic. The most important compound query is the bool query. *bool query, must, should, must_not, filter. The bool query is a fundamental building block for creating complex searches. It takes 4 clauses. *must, documents must match these queries. Contributes to the score. *should, documents should match these queries. Increases the score if they do. *must_not, documents must not match these queries. Does not contribute to the score. *filter, documents must match these queries, but the queries do not contribute to the score. This is useful for filtering results based on criteria that don't affect relevance, example filtering by price range. Filter is typically faster than must because it doesn't calculate scores. This query searches for documents. 1 must have Hitchhiker's Guide in the title. 2 should have genre equal to science fiction, increases the score if true. 3 must not have publication_year greater than 2000. 4 filter to include only documents with a rating greater than or equal to 4.0, does not affect the score. *constant_score query. The constant_score query wraps another query and assigns a constant score to all documents that match. This is useful when you want to apply a fixed score boost to certain results, regardless of their actual relevance. It often used with the filter clause inside a bool query to ensure that only certain documents contribute to the overall score. This query searches for documents with Hitchhiker's Guide in the title or by Douglas Adams. Documents by Douglas Adams will receive a score boost of 2.0. 5. Aggregations, extracting insights from your data. Aggregations allow you to perform analytics and derive insights from your data. They are similar to group by clauses in SQL. Aggregations are defined within the aggregations, or AGS for short, section of the search request. Let's look at some common aggregation types. *terms aggregation, finding top terms. The terms aggregation finds the most frequent values in a field. This is useful for identifying popular categories, authors, or tags. This aggregation calculates the top 10 genres in the my_index index. *range aggregation, bucketizing numeric data. The range aggregation groups numeric values into predefined ranges. This is useful for analyzing distributions, such as age groups or price ranges. *date_histogram aggregation, time series analysis. The date_histogram aggregation groups documents by time intervals. This is essential for time series analysis, such as tracking website traffic over time or analyzing sales trends. Average, min, max, sum aggregations, numeric statistics. These aggregations calculate basic statistical measures for numeric fields. 6. More advanced DSL features. Highlighting, showing relevant snippets. Highlighting allows you to display snippets of text from your documents that match the search query. This helps users understand why a particular document was returned as a search result. Customization *. You can customize highlighting by specifying options like pre-tags, tags to use before highlighted terms, and post-tags, tags to use after highlighted terms. Sorting, ordering results. You can sort search results based on one or more fields. Pagination, dealing with large result sets. Elasticsearch uses from and size parameters for pagination. From, the starting document index, default is 0. Size, the number of documents to return per page, default is 10. Scripting, advanced data manipulation. Elasticsearch allows you to use scripts, example painless, the default scripting language, to perform advanced data manipulation during queries and aggregations. This is a very basic example, but you can perform complex calculations and logic within scripts. Note that scripting can impact performance, so use it judiciously. Also, make sure scripting is enabled in your Elasticsearch configuration. Boosting, influencing relevance. Boosting allows you to influence the relevance score of documents based on certain criteria. You can boost entire queries or individual fields. 7. Mapping, defining your data structure. Mapping defines how Elasticsearch indexes your data. It specifies the data types of fields, how they are analyzed, and other settings. Explicit mappings versus dynamic mappings. Dynamic mappings. Elasticsearch can automatically create mappings based on the data you index. This is convenient for getting started, but it's generally recommended to define explicit mappings for production environments. Explicit mappings. You define the mappings explicitly before indexing data. This gives you full control over how your data is indexed and searched. Data types. Elasticsearch supports a variety of data types. Text, for full text search, analyzed. Keyword, for exact value matching, not analyzed. Integer, long, float, double, numeric types. Date, for storing dates and times. Boolean, for true/false values. Geo_point, for storing geographic coordinates. Geo_shape, for storing geographic shapes. Nested, for indexing arrays of objects. Object, for indexing JSON objects. Analyzers, tokenization and filtering. Analyzers are used to process text fields. They perform tokenization, splitting text into words, and filtering, removing stop words, stemming words, etc. Standard analyzer. Default analyzer. Tokenizes on wit space, removes punctuation, and converts to lowercase. Simple analyzer. Tokenizes on non-letter characters and converts to lowercase. Wit space analyzer. Tokenizes on wit space. Stop analyzer. Similar to the standard analyzer, but also removes stop words, example the, a, is. Keyword analyzer. Treats the entire input as a single token, no analysis. Asterisk custom analyzers. Asterisk you can define your own custom analyzers with specific tokenizers and filters. Example mapping, creating an index with explicit mapping. Explanation asterisk. Asterisk properties, defines the fields in the index. Asterisk title, a text field for full text search. Asterisk author, a text field with a keyword subfield for exact matching. Ignore underscore above limits the maximum length of the keyword. Asterisk genre, a keyword field for exact matching. Asterisk publication underscore year, an integer field. Asterisk rating, a float field. Asterisk description, a text field. Asterisk date underscore field, a date field with specified date formats. 8. Index management. Asterisk creating and deleting indexes. We already saw how to create an index. Here's how to delete one. Asterisk index settings. Index settings control various aspects of index behavior, such as the number of shards and replicas. Asterisk number underscore of underscore shards, the number of shards that an index should be divided into. More shards can improve search performance, but too many can lead to overhead. Asterisk number underscore of underscore replicas, the number of replica copies of each shard. Replicas provide redundancy and improve read performance. Example asterisk. Let's put it all together with a complete example including index creation, data indexing, and querying asterisk. Python. From Elasticsearch import Elasticsearch. Connect to Elasticsearch. ES equals Elasticsearch, host, localhost, port, 9200. Index name. Index underscore name equals my underscore books. Mapping. Mapping equals. Properties. Title, type, text. Author. Type, text. Fields. Keyword, type, keyword. Genre, type, keyword. Publication underscore.